Totally. All right, so we're here in IPv6 world again. We're doing a lot of work on it with Channel 9 right now because it's very interesting technology.
Yep.
And why don't you tell us about yourself? Who are you? What am I doing here today?
So I'm Mike.
Cool. And I notice on your door, you're the Church of what?
Barrettism?
Barrettism. Okay.
Yeah, it's an individual thing with me.
All right.
I'm the only member and reverend of it, but yeah.
Excellent. All right.
So we definitely, encourage IPv6 wherever possible. So I'm a tester for Microsoft. Been test lead and everything, and kind of a technical lead on the V6 team for since we've been working on IPv6.
Wow.
Except for the original preview that wasn't actually going into any product that the research team did.
Okay.
And been working at Microsoft now over 12 years, a long time.
Nice. Wow.
So, and been doing networking and operating system stuff the entire time.
All right. And I mean, you guys just, we just released Vista, and you guys rewrote the networking stack.
Yes, we did.
Which is pretty impressive.
Usually
yes. And now, IPv6 is turned on by default in Vista. The average user doesn't really, care about that in the sense that they don't really know what that means.
Yeah, and that's a key fact for networking at this point.
Okay, so for developers, how do I take advantage of that? Like, what do I do? How do I make sure that my app is IPv6 compatible?
So one of the things you just said is kind of a key stumbling block for doing V6 in some ways. Okay. Is because average user, even the average developer, is so used to IPv4 just working now, they no longer understand how it works as well as some of the developers, like let's say in 98 timeframe or 95, when TCP/IP was a new protocol. People had to understand how the networking worked to be able to set up their tests and do everything. Now, since it's just integrated to how everything else works, and all the other protocols have gone the way of the dodo, including the companies that wrote them no longer support them. Let's not name them right now. Okay. But they're just used to V4 working, so not as many of them understand. And to usually guide people on how to do V6, you start with, well, this is how you do it in V4. Well, since they don't really understand as much of what's happening with V4, it becomes a little bit more challenging to give a quick explanation of how do you switch to actually understand it. Because at that point, you have to learn all this information that before you really only needed to know, I resolve name, I connect, everything's happy. Now you need to know, I resolve name, what type of address am I working with? Let's make sure, how do I configure my machine to specifically talk V6 if I'm trying to actually test, did my application go over V6 without having to run a network capture analyzing program to say, oh look, yes, it went over V6, ship. Something that's more of an automated fashion to force that sort of thing to happen. So. Okay.
So, I mean, one of the things about IPv6 that I'm hearing is that the actual construct of an address isn't really important. So in the sense that, what I mean by is you have this giant thing now, and the developer really shouldn't really need to think about that thing, like memorize an IP address, or if the IP address equals this, that kind of junk.
The only time that he should is when you do name resolution. There's AFINET and AFINET 6. You need to know what type of address you're dealing with to make specific calls, and that's the only thing you need to do.
Cool.
So you need to, and in the programming documentation, that's all there, and it's very easy for the strict developer that's only developing to kind of follow that guide and go, oh, that's all I need to do, that makes sense. It's a different type of address. I don't care what it actually is, but
that's what I mean.
It's really easy for him. Now the guy that's testing it
is
going, wait, I need to actually get this addressed on the machine. I need to put it in DNS. I need to make sure that DNS actually works, and potentially set up a V6 network, because most corporate environments and most people's home environments don't include V6 by default. There's not, you know, our lovely IGDs that I have in my office that we're testing for Vista, they don't advertise V6. They will eventually, and many of them are working on it. But at this point, most of them just give you straight V4 access. So if you're trying to test something in a small business or somewhere else like that, or even in many corporate environments that they haven't rolled it out to the corporation, you'd have to set up some sort of test bed. And in setting that up, you'd have to understand it, because the ITG area isn't going to own that until they actually take the deployment.
Okay, so let's dig into that.
So Microsoft actually has been key into that, and our program management team early on was really good at driving MSITG to or OTG or whatever they're called today, to put V6 in as many buildings as early as possible, to really be a key driver of this and be a partner with us. So it was somewhat easy for us there, but granted, since we're a core networking team, our test labs and setting this stuff up was not that difficult for us. Why? We understood what it's doing. We had to. We're testing that. Whereas the team that's right above us, that is just making the API calls but need to test it, it becomes much more of a challenge for them. So if you do have an IT department that you can say, hey, we really need to do this, and get the IT department behind you, you'll already have that person that has this strong networking understanding, or at least you hope he does, or she does, and then they can go and fill in their holes of V6 and then try and help you out there. Whereas if you're the developer trying to roll it out, you need to get in there, configure a machine to advertise routes, you need to configure machines to be a DNS server, and then forward things to your real DNS server and have your own little zone that is where you're going to have V6 specific testing, and such like that. So to make it so you can actually enable V6 name resolution and such. Though any DNS server would support replying with a quad A record, is what they're called, which is a normal record's an A record, so, and quad A is just 4 times bigger, hence the name.
Makes sense.
And any server will normally be able to give this record. You'll just ask for it and it'll give it back to you. But at the same time, if you want to have it actually listening on V6 and be able to do like a V6 only type scenario testing, you need to, usually most of them would have a special configuration until Longhorn server ships that would enable listening to V6 and allow for your V6 only testing to continue or go on. And then if you're testing, let's say in a dual stack scenario, which will be most people's cases, you'd actually probably still want to set up your own little domain that you could actually control the addresses to absolutely confirm that it's going over V6 at that point, that when you do the name resolution call to say look for this record, if there isn't a V4 record there and there's only a V6, at that point you're fairly certain that you're going to actually be going over V6. And if it failed, it didn't fail back and use V4. Because the recommended way to write programs now is to get the list of addresses and trying to connect to all of them. And whichever one succeeds, use that address. So if you get 2 records back and the V6 record is tried first, it fails, then you try V4, and your application succeeds, it's much harder to determine, well, where did I actually go over? Whereas if you only can resolve that record to a V6 record, and you make that same call and it fails, then you can go, okay, now I know what failed in that it is not actually working in V6, and you can start debugging at that point which portion of the code is failing. Is the side not listening, or you not resolving the name correctly, or what?
So as a developer, then how do I set up Vista to play around with this? I mean, let me ask, basically, how do I turn off V4?
It's a simple command, netSHIN, or if you want to spell it out, interface, IPv4 uninstall. You run that, it'll say you need to reboot, and you're done. Simple as that. Might require a little bit of configuration at that point, depending on how you actually set it up. There is some test documentations kind of explaining that we have up on the website currently that gives how to set up your own little domain, and in setting up the domain how to actually make your router. And the important thing with the domain that makes your life a little easier is you actually already have like DNS servers and stuff like that as part of the domain. Okay. So it can make, and like DNS name registration is easy in a domain because it should be automatic at that point normally.
Okay.
Especially if you configure it the way we told you to, that it is actually dynamic. And therefore you have a way to do name resolution similar to the way that like Wins works today, where you actually, the client or a administrator doesn't have to go in and add all the records. It's dynamically added. And then you can easily configure and go make a call, and when the machine's IP address changes, it matches it. You can easily find the machine, as opposed to, oh, we got a different address this time because I changed, I reinstalled the machine, or I changed the network card, what have you. It makes it much more beneficial to have some sort of dynamic way that you don't have to. You have much less guesswork at that point.
Okay. So we should probably like sketch out how I could set up a little shop for IPv6. I mean, a lot of people are curious, So how do I deploy this stuff, right?
Okay.
We're talking about. We spent time talking about the theory behind it in other interviews, and then the API we've gone over. So now let's actually dig into like the real world a little bit.
Okay, so I'll go over more of an overview. There's documents that are out there that says how do you actually, the specific commands to set up a router and what they do. I'll kind of go over more the overview of what it does and how it works as opposed to here's the commands that you do, because the commands are not difficult to follow when you have the document, but just going through them,
that's fine. I mean, it's the high-level architecture stuff that's more interesting for a video interview.
So, let's erase what's there. So let's say we have our magical blob of whatever, CorpNet. We'll just say it's a corporate environment.
Okay.
And so it's just a magical blob, and you have your little private network here. Okay. That's connected to whatever CorpNet blob. So it'll have your other DNS servers and what have you.
And that'll be an IPv4 blob.
Most likely.
By default, I mean.
At this point, yeah.
Sure.
I mean, unless you're running NetBEUI in CorpNet, which I really doubt it, and you're probably not running any of our current products. Okay. But what you would do is you would have some sort of router in between here. Now, the best solution is to actually have a hardware router that supports V6 natively. So you would add whatever updates or configuration for your router to support V6, and it would start sending out advertisements. Now, since, like I said, a lot of these are controlled by an OTG, ITG situation, you can't always have this as a given. So the next step would be to take a Windows machine, or any other type of machine that supports V6, but we like Windows.
Yes.
Enable V6 on it, so this could be...
So if it's Vista, it's already enabled.
It could be another Vista machine.
Okay.
Or it could be a Win2K3 machine.
Okay.
If you have Win2K3, and it even could be XPSP2 for what I'm talking about this. And what you just configure this one up to do is to be a router and send out what's called RAs, which are router advertisements.
Okay.
So here's Mr. VistaBox. When he comes up, when this guy's configured to be a router, he will send out what's called a router solicitation. And that's basically soliciting, saying, hey routers, tell me what my prefix is, which is the beginning portion of your address.
Okay.
And when you configure this one, he will start replying to everybody saying, this is the routes I'm advertising, here's the address for your configuration. So at that point, this guy knows what his prefix will be. Let's say, 2001/98/68:3:/ 16, 48.
Nice.
Doing the math really quickly in my head.
Okay.
That was kind of bad. So you will take an address, and then what you will do is you will, the machine will append its randomly generated, or actually now it is randomly generated host ID for its permanent address, and then it will also configure temporary addresses based off of this. So you'll have, when you do ipconfig, several different addresses now on this machine. The only other thing that you may want to do is, if you wanted to do a dynamic configuration for this machine, you would also have to have a DHCP v6 server. Now, problem with this is the only one we have is for Vista's Longhorn server, so that's not readily available. If you have another solution that's out there that can do it, you can do that. You would need to configure this machine to set specific flags for the router advertisement that are documented for DHCP v6. You can look for DHCP v6 on the internet, and those flags are readily available. I don't remember if Win2K3 was able to support it, and I don't know if it was added because that was done post us doing it. Now we've actually added the ability to add those flags, so there are ways to actually set them. But any normal standard router would be able to do that, or you just configure this machine and statically set the DNS servers. If you statically set the DNS servers here, he'll still be able to get the router advertisements. If you don't statically configure them, then you still need to add a DNS server, most likely. And if you add a specific address called FEC0:0:0:0:FFF:1, what these are the well-known DNS servers. Well, there's actually 3. There's 2 and 3 as well, but you only need one. These would be automatically configured, so you could configure this to have that address and then advertise it, and you'd have to probably either configure a route on it to say this machine is that or whatever, but the easiest thing to do is to actually have this machine's real address and actually statically configure this, which is our documentation walks you through running a netsh command to set the v6 DNS server. And once you set it, it still will be able to use the router advertisements to dynamically configure its address, but it'll be using a well-known DNS server at that point.
Cool.
And that's the easiest and best recommended way, because otherwise you have to understand these, and these are site local addresses, or the FEC0s. They've been deprecated, even though the OS kind of still supports them on the standards. They don't exist anymore, so it's harder to find specific documentation on the site local addresses. So configuring them and using them, some services and some operating systems don't actually support them. Ours still does, because it was there, it was used, and we didn't want to remove the support for them in case a deprecated service relied on it. And in the beginning, these were the ones that were going to, the well-known DNS servers were going to use site local addresses. So we kept that as the default configuration if you don't have a DNS server. But it's pretty much as simple as that. And then once you get, once you basically have, let's erase all this and put it bigger. So once you have your little configuration here of your router doing RAs and whatever machine you have as your DNS server, technically these two machines could be the same machine as well. Most likely you want to have, like in our documentation, a lot of times we have you set up a domain to be able to join it and be able to talk over v6 and everything. You have your Vista machines just sitting here, and you run the one command to say turn on v6, or you run them with or without, and it works. The only other way is you can use a thing called ISOTAP, which is a tunneling solution. There's a lot of transition technologies that are used for v6, considering that v4, like you said, is so much more prevalent. There are tunneling technologies that have been developed to tunnel over v4 and actually do a v6 connection. So
like Teredo server.
Teredo is a key tunneling technology, but that one's really designed for more of a home end-to-end peer-to-peer connectivity solution, as opposed to if I'm testing in my local network, I'm not going to have access to a Teredo server, so it probably wouldn't work as well. If I'm in a home environment doing testing, Teredo solutions are actually a very preferred solution because no one's going to have an ISOTAP. You know, if most people are behind a NAT or something like that for the most part, so you'd want to actually test with those type of solutions. But if you're testing in a controlled environment, you'd probably want something like ISOTAP. ISOTAP would be just like a router. All you'd have to do is name this machine, even by default, just ISOTAP. You'd have to go through our documentation of how to enable a machine to be an ISOTAP server, which is not all that difficult, a few NetSH commands, and at that point this machine will come up, it will try and resolve the name ISOTAP or whatever. You can actually change the name if you want to as well. Once it resolves the name to a v4 address, it'll go to this v4 address in a tunneled way and send it a router solicitation in a tunneled packet, so it'll be actually a v4 packet encapsulated inside there. And then this machine will tell you and come back with the same little prefix, and then you'll have like that prefix again, like 2001 9868 :18, and then you'll have : and then you'll see your IPv4 address. So like 10.0.0.3. One other benefit of this is all other tunneling technologies. Like there's another one called 6-to-4, which this one is automatic as well. But you can't use private range addresses. So with 6-to-4, you can't use 10, 172, 160, 192, 168, or any other, 169, 254. All these different types of addresses are denoted as being private on the internet. So anything that's denoted that way, you can't actually use with 6-to-4. Whereas ISOTAP, it will use whatever address you had on there as long as you could talk to the ISOTAP server and get a router advertisement from him. So he'll kind of configure it, and then you'll be able to use that. And then at that point, you don't have to do the configuration on this machine to actually support and do router solicitations on an actual native v6 mode. It makes it a little bit easier for certain people who already kind of understand v4 addresses, because at that point the IP address this machine will have will always be deterministic, because it will be this plus the v4 address that you already have on the machine that you probably already know. So you might be able to more easily transition to that technology than to transition right to a native v6 type of topology.
Interesting.
So those are the two easiest solutions for basically setting up a small network. So
nice.
It's either configuring a machine to actually advertise routes in a native mode and really make it would only make this segment between CorpNet and here a v6 native network, but for all extensive purposes these two machines don't know that. They think it's a real network that can go wherever, just like if you configure a v4 network that is technically connected to Corp, but
which is great.
It has a different range, it's still not going to know about it. So it's both ways are good. ISOTAP is probably easier for a lot of people, and you can even potentially get ITG or something like that to roll those out. You could get your IT department to potentially roll out an ISOTAP server and say, hey guys, all you got to do is put the server out there, it's stateless, and it will work for us. How about that? And you don't have to change any routers, you just need to put a decent Windows machine out there.
Yeah.
They might be able to buy into that and say, hey, this is a solution for CorpNet, and we'll even own that. So
cool.
Whereas setting up and getting your whatever X router to actually support v6 might be a little more difficult.
And then your developers can party on
v6 and
in a private controlled network.
And into an application now, granted with ISOTAP, since it's tunneling over v4, you can never actually test v6 only. Why? Because
it's tunneling over.
Yeah. Hence the whole problem.
Sure. So I mean, let's just to bang home, really why it matters that it's purely IPv6 versus IPv4. I mean, are we talking about performance enhancement, security enhancement. Let's talk a little bit about what that really means.
So the benefits of V6 is really one key one that will hopefully eventually be there is global connectivity. So as most people know, America is, fortunately or unfortunately, since we made the internet in some ways.
We did?
Yeah, we did.
UC Berkeley, a couple of crazy professors.
The original stuff was designed here. We actually own most of the IP addressing space, so we're not running out of addresses as much as some other countries are. Even though we probably have as many computers as they do, you can still get a global IP address to your house. So peer-to-peer connectivity is not that difficult, whereas some countries, to actually get it, to actually work, you're natted behind a NAT that's behind a NAT, and then that guy finally has, V4 connectivity to the actual internet. So V6 allows for a global peer connectivity with your application. So your application, there's many applications that have been written to allow for peer-to-peer connectivity, and they have to design all this, how to tunnel through a NAT and how to do all these things. Whereas eventually when native V6 addresses get assigned to the end node, you get peer-to-peer connectivity all over the world. And with the huge addressing space of V6, we should not be running out of addresses anytime soon. That's why they made it, and that's why that we didn't just double the size, we quadrupled the size to make it much less likely that we'll be running into the same problem anytime soon.
Very cool.
So that's the one key benefit V6 gives you. Other than that, there are some inherent design benefits in some ways. It uses less broadcasting, more multicasting. You get a little less traffic on your network in the local area, because like name resolution as opposed to, or not name, address resolution will go over a like a multicast kind of, and it's not multicast to everybody, it's multicast to a smaller group, so not as many people will have to receive the packet and get the packet. A smaller number of machines would actually get it, and then the one that it's intended for would reply back.
So it's smarter.
Yeah, right? It's much better designed. It doesn't use broadcast, it uses multicast, which is much more efficient for your network, so you can get a little more efficiency out of your network in a V6 only environment. But most corporations are already designed to be able to handle as much V4 traffic as possible, so they're not really running into that. And if they are, usually they will change their subnet. But V6 inherently is less chatty than V4 because of the lack of broadcasts.
So, I mean, it brings an interesting question, because IPv6 has been around for a while. And, clearly with the advent of Vista and clients that are natively IPv6 capable, we'd imagine that things are going to start to change. The question is,
how quickly?
How quickly are we going to? Is this going to start changing?
A really good thing for the V6 program and overall has been the United States government of starting to say we're mandating this. The Department of Defense and some of these people that are saying we want to move to this technology. We see the benefits of it, and they want to use the technology. So. If not, really, there were many countries trying to move and adopt to V6. Why? Because they were running out of addresses. So this was their only solution, and V6 was a solution for them. American companies and in places here were not running into the problem, so we weren't driving as hard. Now with the government really getting behind it, it actually helps a lot to me.
Absolutely.
A lot of people now say, "Oh, you mean I have to do a V6 application now because the government won't buy my stuff otherwise?" And to get a Vista logo, you need that type of, you need to support V6. I think, I'm not positive, being a tester, I don't pay attention to that, but it's a good idea to do that because
But we have that dual stack support.
Right,
at the API level,
right.
Underlying system will take care of that.
So if you have an existing V4 application, it'll work fine. But if you want to, I don't know if our logo requires that. I don't know if we logo applications really that often, anyways. ways, but it's best to support V6 in your application going forward, because then you'll get the inherent benefits of it.
Absolutely.
When it is there, and certain people.
And it is going to be there.
And it will be there, and eventually, the world has to move to it. I mean, the statement that why would you ever need any more than 640K of memory?
Yeah, exactly.
That is a fairly, I guess popular, wrong word, but whatever. It's a well-known statement from Bill Gates that is fairly humorous at this point, because at the time it made sense. Now you're going, I have 10 gigs in my server, so I think there's a big need for more than 640K.
Certainly. Absolutely. And I mean, when one of the interesting things will be from a developer point of view is when you have a IPv6 playing field, the type of creativity you'll be able to implement from like a peer-to-peer.
Well, yeah, because you have to spend less of your mental energy on developing, how do I tunnel, how do I get peer-to-peer connectivity, how do I get my cell phone, and that's really, devices like cell phones, TVs, all these type of things can really benefit from the huge addressing space of V6. Because, with V4 you were so much limited that, there was only so many addresses you could hand out. With V6, that's really not, as big of a concern. There's one, when you actually do the math, there's enough V6 addresses for, an IPv6 address on every 3 on every square foot of the planet or something like that.
Nice.
So,
okay.
I can't remember the actual statement, but it's it's a huge thing that we're not really looking at it and going, we're running out anytime soon, and it allows for that type of growth for devices. So when you want to talk to your device or whatever, you can start writing a V6 application, and eventually when all these things move to V6. You have that global connectivity, and you can start focusing so much of your development time on just your front end, your cool features, as opposed to going, okay, now this connectivity thing has to work.
Absolutely.
No matter how pretty you make something look and how many features it has, if it doesn't connect, it's a useless device.
Absolutely.
If I can't, place a call or do whatever and have that be reliable, it's useless to write the application at that point.
Absolutely. And I mean, we're providing much like we did with .NET, we're providing that level of abstraction for programmers to not have to worry too much about the networking stuff. You don't have to be a networking specialist to write a network-enabled app on V6.
And like I said, the only difficult thing is when you come into the testing aspect, because this was the same pain that came, back in '95 and such, when people started writing TCP/IP applications, is they had to understand the networking infrastructure to be able to test their application and to be able to properly do everything. Whereas now, since all the IT departments, every home has it, it just is become, fire and forget. V4 just works, and if it doesn't, then you call someone who fixes it.
Yeah, exactly.
Whereas V6, that you call the guy and he's going, well, we're not supporting it yet. You got to wait.
Yeah.
So when you get to that point, then yes, it will be nice. And if you're ahead of the curve and you're already ready for V6, when people start moving to it, you can get the inherent benefits from it.
Totally. I mean, developers should start now when they're writing their Vista apps, for example.
Yeah.
Write them V6 and V4
yeah.
Compatible, so they can run on XP as well. Now there is a challenge there with how you, if I wanted to write an application that'll run on Vista and
I
XP.
really actually disagree with that. 'Cause,
okay.
See, now for XP, and specifically XPSP2, even XPSP1 to the most degree, the only thing not supported in XPSP2 that you would really need to really try a V6 only scenario is the ability to resolve names and DNS things over V6. You can easily do all this name resolution over V4. It's just XPSP2 does not support doing name queries over V6. Win2k3 actually does. So you can actually technically mostly turn off V4 by, you know, unbinding it from the interface, configuring DNS servers similar to what we told you to do with Vista, and many things will work. You'll get file system support. You'll get HTTP. There's many services in Win2K3 that actually supported V6. Unfortunately, there's not really any services that we could get in the XP timeframe to actually support V6. So that's really the major limitation. If you have an application that works with V6 and you install V6 on an XP platform, there is absolutely no problems with it.
Cool.
There are some updated APIs for Vista to broaden your ability to do things with V6 that you could do with V4 in down level things, specifically around like IP help API. This isn't really a common area that most people, most developers really touch, because IP help API is really the APIs to go in and check and get networking information. So really those are usually networking centric apps that you're running. Something like some sort of IP config that you're writing to do something specific to configure, get information and display information, or what have you.
Okay.
Tunneling technologies or something like that would be a key user of an IP help API type call. We've extended those, and so if you were using those and you're using extended ones for Vista, that's the one area that I could see down level that you'd have to, you know, do a dynamic load and say, okay, do you even support this API, or what platform are you? Okay, if you're not this platform, don't even do this call because it's going to fail miserably. But so you could extend your features for Vista, but for standard WinSock, there were a few calls added for Vista, but nothing that really. Basically, we extended the feature a bit. All the standard calls that you're going to make are going to be really identical, and XPSP2 works very well for your applications. It's just unfortunately in many of the services, so you couldn't do like a file copy. But if you're doing a connect and you're transferring the file for us, works great. If you write your own FTP client inside of there, though actually one client service that is supported is WinINet. So if you're actually making core OS FTP calls that were done with WinINet, those actually do support V6. So the browser actually supports V6, and you can use V6 and XPSP2 in the browser because WinINet and those protocols actually were supported. But as a listening service, there were no listening services like the file and printer sharing didn't support it. DNS doesn't support it because it's much more difficult to get updated features into a service pack than it is when we were developing Win2K3.
Very cool. So what happened to IPv5?
It was an internet draft, and it just pretty much went away. Okay. It wasn't. I think it was a. As I remember, I looked at it, and it's kind of a joke because you just read it. But it changed the scheme. It didn't extend it enough. And I think it was going the way of kind of like IPX, and as I remember, I didn't, we more just laugh about it that it didn't, it exists, so we couldn't have called it IPv5. And when they're writing new RFCs, they had to go, well, this is V6, and everybody's like, what happened to V5? Well, you can go read the RFC on it. No one used it. So there is RFCs for IPv5, and I don't think anybody ever implemented them. Okay. V6 was, especially in the beginning, an IETF-driven project. Microsoft became key into that, and really, frankly, I think we did a great job of driving V6. Before that, it was a lot more, I guess, intellectual as opposed to practical. And when we started looking at it, saying, okay, how do we practically really make this a viable thing, and we started working with some other companies that were doing the same thing, and it was, when you have smaller people putting V6 into things and saying, yeah, we have V6, when you have companies like Microsoft and Cisco and Juniper and Extreme and all these type of people saying, okay, we're doing V6 now, that's when you really get the overall development of V6, and you get a nice driving force behind it, as opposed to, hey, this is a nice intellectual process to go through of how do we make something better from, how do we take something that's existingly good and make it better. You know, a peanut butter sandwich wasn't bad, but when they added jelly.
Yeah, you got it. Excellent. Well, hey, you know, you have any other things you'd like to share with testers? I mean, how do you testing these apps that you get? I mean, we basically covered what you need to look for.
Yeah, I mean, the first thing in testing, get familiar with the commands like ping, ipconfig, and make sure you have simple connectivity there when you're testing something. Do a ping first, and if you can't ping the guy by the name you're trying to connect in your application by a V6 address, I'm pretty sure that it's your application isn't going to magically start working either. So,
Sure.
Those type of tools can be excessively helpful when doing that type of testing, and many people have kind of forgotten how it works. So when doing pings now in our platform, since it does actually do a name resolution, ping is a simple testing application, not an actual working application. So it just grabs the first address in the list and tries to go to them. Now that is really, in our documentation, a bad way to do things, but it's a troubleshooting tool. It's not an actual application. So it will just try one of the addresses. So you'd want to do things like NS lookup and use like type -- all, and then do the name, and then that will tell you all the addresses that came back in the name resolution, and then you can ping each one of those and say, okay, did any of these work, as opposed to just doing ping and going, oh look, I can't get to the one address. Applications should be smart enough to say, hey, I can't get to the first one, let me try the second one.
Sure.
And with V6, that can be a much more common behavior, because you can definitely have many more addresses on a single machine. It can have both an ISOTAP address and it can have a global V6 address. So let's say you have two private networks that aren't connected over the native network. Well, they update their global V6 record that they think is there. They also put in their ISOTAP record. Well, technically your two disjoint networks can only talk over ISOTAP, and they would fail the other one. So if it just called into the, let's try the native one first, oh it failed and it gives up, that would be something that you'd want to look for and test. And ping would actually show a failure in that case. You do ping and it would say I'm pinging this V6 address, and it would never try and ping the ISOTAP address. So you'd have to go one step further and do NS lookup, find the addresses, and then at that point ping those addresses directly and say, do any of these work? And you can use little things like telnet or something like that as well. After you see that ping works, you telnet IP address and protocol and the number of the protocol you're trying to go to. Let's, in HTTP case, it's port 80, and at that point you could see, can I even establish a connection? If you see a little blank screen at that point, you go, okay, I know that TCP is starting to work. Maybe there's something above there that's failing. And you can assist the developer with getting a little bit farther instead of just going in a black box. I don't know, stuff wasn't working,
Sure.
And have the developer have to come in and do all that type of work. You could become more being the network aficionado for your dev. Then you could go, hey, when we tried to connect, we only tried to connect to the one address. He'd go, oh, instantly I can write a fix for that, as opposed to him going in and scratching his head, figuring out your configuration, and then coming up with a solution for you.
Absolutely. All right. Well, hey, thank you for your time.
Thank you.
And I'm looking forward to an IPv6 world.
Well, it's already here.
Yeah. But
Microsoft, it's all over the place.
Cool. Excellent, man. Take care.
Thank you.